So we are excited to kick off our panel on robotics and off-road transportation. Joining me on the panel are Dr. John Saul, founding director of New Horizons Studio, CRADLE, and Hyundai Ventures at Hyundai Motor Group. We also have Brian Ringley, product manager for construction at Boston Dynamics, and Sam Poirier, CEO of Potential Motors. All right, well, thank you everyone for joining today. I appreciate it. So maybe we could start first with an overview of each of your organizations, and we'll start with John, please.
Hi, everybody. Once again, my name is John. I lead a team called New Horizons Studio, and what we're about is designing and building a novel type of vehicle, ground vehicle. What makes it novel is that we're combining robotic technology to what I might consider traditional car design, and that intersection of the two results in a ground vehicle that has a lot more mobility than a car with a conventional suspension. And we're part of the Hyundai Motor Group R&D division, and really part of a really bigger initiative from Hyundai Motor Group to go beyond a say traditional car manufacturer into a provider of smart mobility solutions. So great to meet you, and looking forward to today's panel.
Thank you, John. And Brian.
Yeah, my name is Brian Ringley. I work at Boston Dynamics. Boston Dynamics is a robotics company. We have a mobile automated case handling solution for warehouse work called Stretch. We have an R&D humanoid robot called Atlas. You might have seen that one on TV or the internet doing backflips. And then we also have Spot, which is a quadruped or four-legged agile mobile robot that we use for industrial inspections. And I really focus on construction applications and use cases for Spot.
Great. And Sam.
Thanks for having me, Scott. So yeah, I'm one of the co-founders and the CEO of Potential Motors. So what we are focused on is building the future of off-road driving. So off-road has really been quite similar for the past decades in terms of what those vehicles look and feel like in the power sports industry in particular. So what we're doing is using a software-based approach to look at what these vehicles can look like in the future in terms of how we control them, how they're used as electric vehicles and driving the off-road to enable more people to be able to get into these vehicles. So really our core value is around the perception stack for understanding how these vehicles drive through different types of terrains, and then the control systems for reducing complexity of actually designing these vehicles.
Great, thank you for that. And just to kind of set the context, we have ample amount of time, so we're just looking for relaxed conversation, and feel free to go into as much detail as you like. Again, we have plenty of time. I think easily 45 to 50 minutes with Q&A at the end. So let's start broadly with robotics, and then we'll gradually shift over to transportation and then to off-road. So starting with Boston Dynamics, I know that, having spun out of MIT and then been acquired by Google X and then SoftBank and now Hyundai Motor, how has the change in control and ownership affected, or maybe not affected, the focus and the portfolio of Boston Dynamics?
The history definitely precedes me, but I do know that Google was really the genesis of the Spot project, the idea of taking the prior larger quadruped robots that were the first ones out of the lab and finding a way to make those the right size to move into human purposed environments. So things like, how does a robot go up and down stairs, and how does a robot move through doorways? And that really kind of set the stage for this thing having commercial possibilities. So under the ownership of SoftBank, that was really when the commercialization started. Spot went on sale in 2020 after some early adopter testing in 2018 and 2019. Once we were comfortable with product market fit, then we were able to put that on the market, and SoftBank was really instrumental in making that happen, as well as kickstarting the work with the warehouse robotics. And now under the new ownership of Hyundai, they really have a lot of confidence in us to continue on that roadmap that we've already set forth, and then a lot of exciting things, I think, to come in the future from that collaboration.
Now, when we think about Boston Dynamics, is of course we've seen some of the amazing videos, including those that's been orchestrated to certain choreography. Is that it's really distinctive in its advanced capabilities. Now, how would you characterize or compare Boston Dynamics relative to other robotics companies that are out there, and what is ultimately the core, let's call it, specialization or focus for Boston Dynamics?
Yeah, I mean, I think the core competency was dynamic robots, robots that are always balancing and robots that are on legs. It was interesting because the stretch warehouse robot is really the first one that has a, I'd say more of a traditional wheeled platform, because the warehouse environment doesn't actually require the complexity of legs. So I think that's the key differentiator, I think, historically for the company, and kind of inspiring people to dream a bit more broadly about what machines and robots are actually capable of in the real world. And then I think when we get more down to earth, I think our differentiator is then, the ability to bring these robots to market and actually commercialize this, fairly radical new technology.
Now, of course, there's a just incredible amount of engineering and science and sophistication that goes into each of these products within the product portfolio of dynamic, mobile robots. But so much of the inspiration comes from humans as well as within the animal kingdom. Why not, create brand new forms of movement and dynamics that doesn't have to rely on, something that forms that we know already?
Yeah, I mean, I think that's a great question. If you look at locomotion morphologies of robots, some of the original research questions posed by early Boston Dynamics were just looking at the fact that a lot of mobile machines and robots were really limited to roadways. And roadways, cover a very small fraction of the Earth's land mass. So the idea was just generally, how do we expand the usage and value of robots, across all types of terrain in the world? And well, if you look at animals cover a lot more ground than, say, cars, for example. So jumping to today and, the work with Spot that started at Google, it became more specifically about, we have built a world around us premised on the way we as humans move, which is primarily through legged mobility. So then being able to replicate that is what will ultimately allow physical automation technologies to come into human purposed environments, trying to shift the thinking around automation from something that you actually have to design your environment for, to something that can just plug and play into most environments as they exist today, because most interior industrial environments are not, in fact, designed for mobile automation.
Now, one of the kind of novel things we've seen is a cross between mobile on the ground, but also the ability to have some limited flight as well. Do you foresee that in the future, Boston Dynamics could experiment or extend its products to things that could potentially fly as well?
No current plans for that, but I would say that there is a lot of interest in finding new robots to build. I mean, that's what this company is all about, is sparking the imagination, building exciting new robots, and then finding ways to, really enrich people's lives and add value to their businesses. So nothing in the works now, but, I would never close us off to some possibility like that in the future.
Mm-hmm. Now, one of the things that I think we like to have a better understanding is, what is a market asking for? Certainly, they may be specific to Spot or specific to the humanoid, but if you had to compartmentalize or classify, what are the kinds of case studies or use cases that you're seeing, and how are you developing to meet those needs?
Yeah, I mean, most broadly with Spot, as we were doing product market fit, we really found that across all of our verticals, whether it's construction or oil and gas or industrial and manufacturing, is that it's about inspections, and it's about autonomous inspections, being able to free up skilled human labor to work on other things and to have these background physical processes that can add on to existing IoT systems to add dynamic sensing to really bring kind of total visibility to your environment. And the reason you want that differs a little bit from vertical to vertical. So for example, I might want that in my manufacturing space, specifically for predictive maintenance, because downtime is my worst enemy. I might want that in utilities because I actually need to send a machine into an area that would normally have to be shut down for human inspection, which is very costly. I might want that in construction to track progress, to pay my trades, and to catch mistakes as they happen, which is much easier to fix and much cheaper to fix than if I end up catching those by accident months later. But across the board, it's really how do I get comprehensive visibility of my complex industrial environment? How do I get autonomous inspections? And that's really through dynamic sensing, the idea of moving sensors through the space rather than relying on fixed sensor systems exclusively. And then, of course, we have the whole warehouse robotics side of things, which is looking at this kind of juncture between all of the warehouse automation technologies that already exist, which is a lot of storing and stacking and order building and just moving things around that facility. And then the kind of supply chain and the trucks coming into those facilities, and really identifying that juncture. How do we start to bring automation to bear on unloading these trucks, which is actually really difficult, time consuming, usually extremely uncomfortable with hot and cold temperatures. And we just really saw an opening there where no one else had a particularly bespoke and reliable solution. And we've really just been building very directly toward that, which is interesting because Spot was really a technology that we had to find product market fit for to commercialize. Whereas with Stretch, that's purpose built for particular warehouse tasks. So it's really nice to see both ways of bringing a robot to market.
Amazing. Great. Terrific. All right. So we're going to transition to John to talk about Hyundai Motor. John, if you could elaborate a little bit more in terms of Hyundai's vision. And again, I think one of the things that Brian had said was that not everything oftentimes travels on roads or paved streets, that we have to have the ability to be able to go off-road. So how do you foresee Hyundai potentially marrying traditional transportation capability with robotics capability?
Yeah, Hyundai Motor Group has stated several years ago that it's undergoing a change in itself and really going from a really manufacturing, centric automotive company, conglomerate into one that is about what we call smart mobility solutions provider. And to unpack that a bit, it's really about, mobility solutions across, different types of different types. Certainly with, traditional cars, as it were, the big change there is to electrification. So there's a, big shift from combustion engine into more and more electrified, whether that's hybrid electric, plug-in hybrid, and fully electric, and also hydrogen fuel cell electric vehicles too. This becoming a smart mobility solution provider also means going into aviation. And so earlier, I think it was this year, that we announced the creation of a totally new entity called Supernal. They're all about this urban air mobility, or I think it's also called advanced air mobility. And this Supernal is about everything from the design and manufacture of aircraft, specifically vertical and takeoff landing aircraft, to the services, the transportation services. And in some regions that might be we actually provide those services, or in other cases we would work with a carrier, to provide those services. And then finally, robotics, and that we acquired Boston Dynamics earlier this year as well. That was acknowledging a lot of things that what Brian already mentioned, the fact that the paved roads, right, as we know them, are only a part of the surfaces that humans need to be traveling or being mobile over, right? And that those surfaces, even though they're flattish, right, they're not necessarily made for either necessarily robots or even cars, right? Cars are just bigger. And so with the mobility through legged locomotion, or even other types of locomotion, then we can get that mobility or that automation, if you will, to where people are without having to reconfigure your entire environment, which might be possible in a factory, right? So, but again, a factory is just one place where humans are in. or even a warehouse. You still need to have people in those places. So with robotics, we extend the mobility of what you might call a traditional vehicle, whether air or ground, into those places that are where people are. And so that is, I think, part of the bigger vision that really mobility, for a car company, right? It's, you can say it's cars, right? But mobility is really a much bigger term than just cars, right? And so it's moving people and things in different places. And so that's where, Hyundai wants to move into. And so it's more places, right? It's cleaner. It's, and just as, safe and affordable, and with the quality that consumers today expect out of their cars, right? And then we want the same to apply to any other mobility product that is coming from Hyundai.
Well, as a car company, the divisions that you've laid out is very bold. I mean, the fact that I think the volumes over the last couple of years have ranged between 3 to 4.4 million cars sold globally for Hyundai Motor Group. Off-road vehicles, robotics, and other mobility platforms. I wonder, is it going to even make a dent in sales, or do they foresee that the new lines of businesses are going to really contribute significantly to the bottom line?
The goal is to have it a very significant part of our overall revenue. So therefore, aviation at large, right, is going to represent 30% of the total group revenue. And then robotics at large, right, is going to represent 20%. So between aviation and robotics, that's 50%. But to your point, Scott, it's close to zero today, right? And so in the short term, it is not, to be frank, not a significant part of our revenue picture. So this all really represents the future of Hyundai Motor Group. And it is very important for Hyundai Motor Group to get into aviation robotics because, as with any business, if you look in the past, right, the past is not what your future will be. And so we have to prepare ourselves for a future where the revenue from traditional cars and trucks is going to be different than it is today. And that's what we're getting ready for. This transition will take time, right?
Mm-hmm.
But that is the direction that the company and the group is moving towards. Again, a future which aviation robotics could constitute 50% of total group revenue.
I mean, that's really exciting. And I think when I look at companies like Honda that have, I think, early on placed their bet on robotics, and I do believe that robotics, humanoids that are essentially companions or helping us at work or in the home, are going to be a massive new segment in the industry, and certainly Tesla is trying to go into that. Whether their claim of having something viable in the next couple of years is true or not, so that we certainly know. And then as far as urban air mobility, if you really think about it, it really is a brand new segment. I mean, traditional small aircraft manufacturers aren't going to be necessarily competing in this. It's a whole new capability based on electric, based on hydrogen, and it just it's going to also change the infrastructure as well, in the sense that we're going to extend beyond the helicopter pads, and even the roads are going to have to change to accommodate cars that can have vertical takeoff. So a lot of potential, a lot of opportunities. But as we have Boston Dynamics and Potential Motors here together, is the synergy. So John, where do you see the synergy between Boston Dynamics specifically as it pertains to off-road?
Yeah, I think especially in off-road, I think this is where Boston Dynamics has a lot of capability and know-how, experience, talent in understanding inherently off-road, right? And it's really through the legged locomotion, right? Because legged locomotion, as Brian said earlier, is the way humans and animals navigate the world, right? So, we were moving around, right, before there were roads, right? And so I think off-road almost, let's say through evolution, that walking was an effective means, not necessarily most efficient, right? But it was a very effective means to navigate the world and surfaces, at random, right? And so almost immediately you think, when I want to go off-road, to really, I think, do it in a way that is going to have the versatility to encounter any kind of terrain, you almost have to you seriously consider. And my thought too is like you have to include some kind of what we might call legged locomotion, or the motion that legs produce will have to be incorporated, right, one way or the other, because, well, again, this is proven to be an extremely effective means of traveling off-road. When I mean off-road, I mean like non-road off-road. I mean, there's off-road as like paved off-road, right? But then there's like off-road, non-road off-road. And I think especially in the non-road off-road is where legged motion and then Boston Dynamics really being at the forefront of that is going to play a huge role in enabling Hyundai to develop products that do the non-road off-road, but also off-road too. But for me, it's the non-road off-road transportation.
I think for those that are watching and listening, it really is a game changer, and it forces us to really change our thought process, because when we think about cars, there's a certain movement and certain control that it has, and to think of having legged transportation vehicles off-road, it is quite mind-boggling, to be honest. But I think where we can start to get our arms around it a little bit more is if we take it to space, take it to terrains like asteroids and places that are much more difficult to traverse, to be mobile. You need every possible way to make sure that that rover is going to be able to transport goods or people in the safest manner possible, right?
That's right. In fact, one of the rovers, I can't remember which, maybe it was Curiosity or its companion, the reason why it stopped working wasn't because it ran out of batteries or solar. It got stuck, right? Exactly. I think, and it was like one of the wheels got stuck of the 6, right? Is my understanding, or something like that. So of those 6, one got stuck. That really disabled that vehicle from going any further. If you had the ability to extricate that wheel, right, and move it into another location, it might have had a better chance of moving, right? And that's where, right, like off planet, so Mars, the moon, etc. You literally have no roads. Now, one day there will be roads, as I believe it, but that's a ways away. But until then, we're going to need these vehicles that are literally no roads. And you're right. I think the case for a vehicle like we're doing is much easier to make if I say we're going to the moon or Mars, because then there's literally no roads.
Yeah. Absolutely. Well, this is mind-boggling and very exciting, and we're just starting to get warmed up with the conversation, believe it or not. So, Sam, let's go to you. One of the biggest questions we have to ask is why off-road? When the electric vehicles are becoming more dominant and really kind of necessitated by the legislation policy, but also autonomous vehicles are starting to go off-road as well, especially around AV. Why should we focus on off-road versus on-road?
That's a great question. That was an interesting train of thought there with John there too. So we'll dig back into that. But yeah, I mean, I think off-road in itself is something that has been underlooked in many ways for a while, except for some of the unique industries that have out of necessity had to focus on it for mobility. But as vehicles become more and more autonomous for on-road vehicles and electrified, and we see this whole generation of future mobility being more focused on shared mobility, where people don't own their own vehicles, they're not driving as much, you're getting driven from place to place without your own vehicle. I think that's when you'll see more of the general consumer looking to places like off-road for different types of driving experiences and things like that, which I think, going back to John's point, that's where different types of mobility become interesting, even just from a general recreation and preserving the environment and experiencing the environment point of view can become very interesting as well. So I mean, in terms of where we find it really interesting, we'll focus more on the on-road, off-road, as you were describing it, in terms of this trail riding, where you do have trails that exist, but you do still have these challenges in terms of the unexpected that you experience in these off-road environments, where you go from in one, we talk a lot with different people who do off-roading and experience off-roading a decent amount, and you can have one off-road experience on these trails that exist, and you'll go from mud to rock faces to sandy areas, and all of this for even an experienced driver can be challenging at times and requires modification to the vehicle in certain ways to be able to get the best experience performance out of it to get through those different types of terrain. So that's where, I think we found it very interesting to work on is how do you use an electric platform without making massive changes to what these vehicles look like today, but really look at using this electric platform that's becoming common in automobiles on road and applying that to off road to be able to improve that ability and capability to get through these different types of terrain and in my mind enable other types of people to get into this driving experience that is off road.
Yeah, the overriding theme for this particular event is around scalability. And when we think about autonomous vehicles and a couple of the actual programs that's active for Waymo, I think in Phoenix and San Francisco area, it's very limited. And the reality is that to put out level 4 or level 5 that's approved by the National Highway Safety Organization is tough because ultimately at the end of the day, we're talking about lives at stake. So the rollout of AV is challenged and slow, and that's part of the reason why VCs in particularly have invested into off-road, indoor, and basically things that are kind of outside of that oversight where you don't have issues around these policies and legislations and hurdles. And that's why off-road is a very interesting topic because it has a potential to allow for AVs to scale fastest. Now, with that said, I want to go back to you, Sam, around some of the technical challenges of on-road and off-road operation, because it's not trivial. I mean, anyone that has actually experimented with ATVs or true off-roading is that it's actually very complex. It's a skill and an art as well. Everything from inflating, deflating the pressure of the tires, changing the transmission, the gears to the torque. Talk about the challenges and sophistication and how today off-roading is done really manually versus what are you guys enabling now?
Yeah, absolutely. So back to your first comment there, that's, that whole reason for investment into off-road around autonomy. I think, off-road is a perfect test bed for many autonomous systems that I think will eventually make it to on-road driving for some of these more challenging types of conditions, which is another reason why we're so interested in it. But going back to your question, that some of the biggest technical challenges really come down to, like, I guess that first comment I made around terrain versatility. You're going through multiple different types of terrain, and you have soft ground, for example, which is something that's hard to simulate in a good capacity. So you have to use real world data to be able to do a lot of this design work that has to happen. And then from the sensors perspective, I mean, in on-road driving, you may experience snow or rain or things like that that can cause disruption to your vision or dust in some areas. But in off-road, every single experience that you are dealing with dust and sand and different type of debris that's coming up, as well as in these trails that we're talking about, you're also having, branches and things like that come into the way, as well as, different moving objects around you. So it becomes much more challenging to work out, localizing the vehicle. Another piece is around GPS, and you're in remote areas, so you don't necessarily get to have access to that as well. So it's looking at, how can you make use of what's on the vehicle to be able to understand the environment that you're in. And that in itself means looking at some unique ways to integrate different sensors to understand that environment and the position that the vehicle is in space, which is part of what we're working on around using optical cameras and radar to be able to understand the terrain that you're passing through and where this vehicle is located in space. But then ultimately using that information to proactively make decisions on how to actually modify torque of the wheels or suspension control within the vehicle so that you're adapting in advance of the terrain that you're going over versus running into a situation where the driver error for many cases or just a mistake where you do end up getting stuck because the tire pressure is too low or too high, or there's various different things that can lead to that. So there's some significant technical challenges, but what I think is interesting about all of them is that I believe they do have a lot of application to the broader, I guess, mobility ecosystem outside of just on-road driving. They can be applied to or off-road driving to be applied to on-road as well.
Okay, great. That I think that's right. And we're going to come back to you and get into a little bit more around the capability of your platform. But the next 15 minutes, we want everyone to participate in this discussion. And first question for everyone is really, I think we're starting to see a lot from research and academia around the use of simulation. So before you actually try to have robots, four-legged humanoids, cars, do its thing on the real road, a lot of the learning, self-learning is happening in a virtual environment. And through those iterations, in some cases, some objects that are in polygon shapes or whatnot can actually learn to quickly walk and move in ways that, frankly, had you tried to teach it some other way, it would have taken much longer. So how are your respective organizations thinking about virtual simulations, not only for the typical machine learning, but really to accelerate the learning process for some of these robotics aspects, off-roading, but also the handling of edge cases that's really difficult to try to recreate in the real world?
I'll get started. So yeah, I think there's been a lot out there, and we're just getting into it, so I don't have necessarily a lot of depth in this. So I think there's I'll comment on two areas. One is I think maybe the traditional use of simulation, for us, very simple. Like we have control software, we have a multi-degree of freedom vehicle, right? It has robotic legs plus the wheels. And so we want to develop the control software to have the vehicle drive over different surfaces or overcome certain obstacles. And so as we are developing the hardware for the vehicle in parallel, or as we can develop the control software ahead of time, and we try to include as much of the physics of it as it were, so that when the hardware becomes available, then we can put that exact same code into our hardware, and then we'll see how close it is to what we seen on screen, right? And this iterative process will go back and forth between that. And so if there's a discrepancy, and there will be, then we have to kind of figure out where is this discrepancy lie. Is in the hardware design? Did we not account for something in that control software? Is our sensing on the actual sensor not updating at the rate that it should be, et cetera? The second of the two areas I want to talk about, though, is maybe completely on the other side of things, where it's more about, I call it educating the customer, right? Kind of plain and simple, because today, we call our vehicles ultimate mobility vehicles, or UMVs. And so if you were to ask somebody, would you like a UMV? They would probably give me a blank stare, because they don't know what a UMV is. And I really wouldn't expect them to, because it doesn't exist. However, in a simulation environment, we can have them experience a UMV doing something, and then they can learn, oh, I see what it can do, and could it do this or could it do that? And then that's actually a way to get customer feedback early on. And so where we're having fun, if you will, driving this virtual vehicle, it's a way to do product market fit really, really early, right? I mean, because even before you even have the product fully defined, you can define the product fit virtually, because you're doing it in simulation. There's also challenges too, because it's the fidelity, right? How well do you have that tire ground, the terra mechanics of it? You probably don't get right, and a lot of things you don't get right, but it's a way to educate the customer, right? And it's a kind of a classic problem that a lot of companies, new tech companies, have, is educating the customer, because they can't even articulate what they want, because it doesn't even exist. And so that's how we're thinking about using simulation, is to learn about what the customer wants, what they need, et cetera, and we feed that back into our product and R&D development cycle early on, and hopefully we'll get to something that people really want, right?
Terrific. Anyone else?
Yeah, I can jump in there. So yeah, I mean, I think we've had a bit of a similar experience in some ways. So we certainly use simulation to help with product market fit, because as a startup, we need to be very careful about how we spend our time and resources early on. And simulation is a great tool to be able to move quickly, make designs, iterate through design, and be able to actually showcase that to people, both for internally on the team and for externally for customer facing to understand, is what we're building actually going to provide value to you in the end? Because that's, always the question as you move along. So, that's been a big part of it in using simulation. But another piece of it has been with off-road, understanding how far is far enough in terms of simulation, because you can dive in deep in terms of how high fidelity the work that you're doing. So, for example, we do use simulation quite a bit for testing vehicle dynamics and how control software interfaces with that in an off-road environment, as well as for the perception side of things. So, for example, we have an off-road environment built that we can drive a vehicle through and basically simulate all the sensors within that. But it comes down to, how much time you spend in simulation in creating a really high fidelity simulation versus doing some real world testing to get data that you can use in comparison with that. Especially because an off-road environment just is so hard to be able to actually properly model in some ways today. So that's kind of, I guess, one of the challenges in simulation today is that decision, but it becomes a very useful tool when you kind of use real world data combined with simulated data to be able to speed up the overall design process and make decisions earlier on so that you are building the right product for the customer.
Mm-hmm.
Yeah, and I can round that out. I would say that we put way more stock in real world data than we do in simulation. I mean, we use simulation. We recognize the value of doing both things, but Spot mechanically just has so many more joints and axes and freedom of rotation, and Spot is also in tight enclosed industrial spaces, potentially knocking into things in ways that cars on the open road hopefully are not. So I think the simulation tools do not provide, the state that stuff is in right now, even though it's moving fast, does not really provide the level of complexity we need and the value we need. So a lot of that is really just about putting the robots out in the real world, collecting data on that, and then using that data to improve the product. And we've always put a lot of pride into that. The machine learning side is absolutely critical for a lot of the computer vision tasks that the robot has to do for inspection, but not for training robot mobility and balance itself, although some companies are doing that to various degrees of success.
Yeah, so Brian mentioned something that's very interesting is that, Spot, as an example, has a lot of joints, rotors, actuators, axes, and so forth. When we think about off-roading, and let's take the extreme case of the moon. You have daytime that is fully exposed to the sun, and nighttime that it doesn't have any sun, and you have dramatic temperature changes and difficult terrain as well. So in situations where we're really doing off-roading on Earth as well as off Earth, is that there's a high threshold in terms of durability, reliability, and the fact that it can last. It's built to last. So the set of requirements becomes higher, does it not? And how do you ensure? Again, cars on the road is a great example of that. But even cars for today isn't going to be necessarily reliable enough for off-roading if, for example, in the context of military, let's say, where it's spending bulk of its time in the Saharan desert, or it's in the Siberian icy regions, for example. So how do you build for things that has to have all this dynamic capabilities and mobility, but has to deal with all these difficult requirements and the durability requirements?
Yeah, I think I'll just pick up on Scott. So yeah, the more harsh environment, whether it's dust, temperature changes, or just the vibration that the vehicle will encounter, you have, and picking up on really, and combined with what Brian said, there's no substitute for like this real world testing. And I think it comes down to understanding your operating environment, the mission or the types of tasks that the product/vehicle will be put through, and then putting that product or prototype, through a proxy or close to the actual, and getting as much data as you can, and then understanding where the likelihood of failures will happen. And then you can do one of two things. In very, very simple terms, you design a solution to fix that, right? To make that a lower probability of occurrence, or you design in a maintenance or overhaul schedule, like with airplanes, right? You run the thing in a certain way and only in a certain way, and then at a certain amount of hours you have to repair it or overhaul it. And I think there's almost no substitute for that. And I think it's just comes down to just really understanding the environment and the tasks, and I think that's why hardware is hard, right? For that reason, right? Because then I think there's no shortcutting it in a lot of ways. And I think the industry kind of understands these things. We just have to set the expectation correctly, right? With the manufacturer, with the agencies, and with the customer, that's what's needed.
Anyone else?
Yeah, maybe a point I'd add to that too is in those environments, you can define the problem, as far as you can, but then in off-road environments, and I mean to the extreme of the moon that you're talking about, there's just situations that you don't expect to happen that will happen, and it's that where we certainly, at least initially, you have to take an approach of working through. You work through as many of the edge cases that you can where simulation can help with that. But it's also, there is some, at least the approach we've taken with some of the prototype work that we've done is some over design in some of the components beyond what you would typically expect to experience in those conditions, just because that you are going to end up hitting some situation that is an edge case that you weren't expecting. One of the biggest problems today in regular off-road driving is that the axles will break. It's just extremely common, and it's a single point of failure for a very good reason, because it means you're not going to blow out your engine. But it's still incredibly inconvenient when that happens. So I mean, there's ways that you can work to preventing that in terms of again, proactively trying to understand what's happening before you actually get to those situations. But ultimately, you still have to understand that there's going to be stuff outside. At least today, there's going to be stuff that you can't plan for, and that means adding in a bit more robustness to design versus what you might do for an on-road vehicle.
Yep.
Yeah, and I think it's just test. We just put in a lot of test hours to improve the reliability of the robots in our customer environments. There comes some constraints there. We know the operating temperature range that the robot system, and particularly the battery supporting the robot, will tolerate, and the charging dock, right? Well, it's not just about the machine itself, but there's usually an ecosystem of things that need to support that machine in that environment. I mean, space is extreme. And you spend way more money overbuilding, one machine, because that one machine needs to succeed. I think for commercial vehicles and robots, you don't want to over design too much, because you need to keep that cost down, and you need to focus on the manufacturability at scale. But I think, the key here, and probably what you're driving at, is by moving into challenging terrain, into off-road, we're starting to build the foundational kind of reliable locomotion systems that would be advantageous for more extreme environments like the moon, like Mars. And I do think there's a lot we can learn from this era of robotics on Earth that could apply to space exploration as well.
Agreed. I'm going to switch conversation to talk a little bit about business models. So, and this could be, I'm not sure if it's controversial or perhaps maybe something that all of you are already experiencing, is that there is kind of this growing expectation broadly on the enterprise customer side to not only consume SaaS, but also consume hardware as a service. So in other words, because we're talking about durability as an example, maybe they don't want to deal with their spot that's down for a day or two. They want to transfer the liability to the manufacturer. So they rather having to pay the CapEx, prefer to do a subscription-based model. Same thing with Hyundai as an example. At some point, whether it's aviation, whether it's other types of mobility or crossovers, is that they don't want to necessarily pay for the CapEx. They just want to consume the benefit of it. What does that mean for you as the manufacturers and developers of some of these systems?
Maybe I'll start. So I think, yeah, there's always this idea that maybe the SaaS model applied to hardware. And I think obviously we've seen that with things like rideshare services, and so we do think about that, and we try to incorporate. And I think it's probably easier, although not exclusive with it, like our aviation, right? So because we're starting from scratch, we can incorporate that kind of thinking, i.e., offering the services or the to our customers, whether it's a fleet or operator or the actual passenger. That said, I do want to mention Motional, which is a joint venture between Hyundai Motor Group and then Aptiv. Motional is a company that's also looking at the spectrum between services as well as the technology for automated vehicles. I think, though, when I think about what does it mean for a manufacturer, I don't think it changes much because of the following way. Because you are now going to offer services, if you will, right? Or something X as a service, right? You still need to have a highly predictive way of understanding what that machine will do, right? It has got to operate with a certain performance, with a certain reliability, with a predictable downtime, or when that downtime will be. And so your manufacturing, your design quality, your mechanisms, et cetera, all have to be excellent, right? Because if you, as a manufacturer, then offering the services and your hardware is breaking down all the time, is bad for you, right? Mm-hmm. And so I don't think it really changes a whole lot in terms of the value and the need for excellence and quality in manufacturing. I think that is maintained. Actually, it's just you're thinking about the revenue from that is going to be different, right? But I think the fundamentals remain the same.
Mm-hmm, mm-hmm. Anyone else?
Yeah, I mean, it's nice. One of the things that I think has been nice for us is finding partners for distribution who can think about that on a kind of industry by industry basis. Because I think it would be hard to assess the value of that just generally for like Spot, for example, because different industries have different needs and they have different sensitivities to CapEx versus OpEx and maintenance requirements, et cetera. So, we've partnered with Trimble, for example, in the construction space. And Trimble has a massive amount of distribution throughout the world. And in some regions, they can provide leasing, and in other regions, they do direct sales. And, you can kind of do what you've always done with your construction equipment and your existing vendors. So I think that simplifies the problem, because I think, we first put Spot up for sale and it was just, it was pretty simple. We sell robots. Now there's a maintenance plan, and, that's something that can be re-upped year over year. But I really think for us, it's about recognizing what we're really good at, which is building robots, and then really finding the right partners in the market who understand the various customer sensitivities, vertical by vertical, to really manage what that paradigm is for providing robots and robotic services.
I don't have too much to add on this, but I can talk a bit from the how this might change in the recreational side when we think about UTVs and off-road vehicles as we move to electric and I guess more software-centered vehicles. Today, typically a person owns their own ATV or UTV, will travel that around on the back of a trailer or something like that. I think as shared mobility becomes bigger and there's more opportunities to be able to travel outside the city or in easier ways to these types of locations, that there's going to be bigger opportunities for more ride sharing to happen with these off-road vehicles as well, where ownership becomes a bit different and the use case becomes a bit different, because typically these vehicles today, they end up sitting at home for a good portion of their life. So, I think that's where in a way, the manufacturability and quality of the vehicles is probably going to have to increase if we do start to see that over time versus, the amount of hours that we see these vehicles go through in their lifespan isn't that high typically. Like, there are the avid riders who will ride them every single day, but I think with those business models that could emerge, we would need to see improvements around reliability, manufacturability on those products.
Absolutely. So I want to change the conversation a little bit to supply chain. So, we're seeing everything from chip shortages to big shift from ICE or internal combustion engines to electric vehicles, and what that means not only at a factory floor level, but the OEM and the entire ecosystem. So as we think about off-roading and robotic capabilities added to transportation, how should we think about everything else, and including component providers that currently do not exist or cannot supply what you need? And you're trailblazing, but yet you can't scale without the rest of the OEM ecosystem catching up, so to speak.
Yeah, that's a great question. I think, and I think a lot of ways there's a core set of technologies like computing, even like say batteries, let's say, et cetera. They're just kind of common. So I think a lot of things are whatever supply chain issues that exist with a lot of components are common to all. But in terms of the new technologies, especially, let's say, I would add to that, if there's an interest in, I think, like product lifecycle management from a sustainability viewpoint, from ground to ground, I guess, right? Then I think that becomes important to understand how do we design a supply chain that incorporates, broadly speaking, kind of eco-friendly / sustainable material cycles. I think that could be challenging because not everybody is in the same maybe level of interest in that, or maybe, I don't know if interest is the right word, but priority. How about that? And I think that could be challenging. And then so trying to find, and I think the good news is, having said that, I feel, right, there's a growing awareness and desire to be more sustainable / eco-friendly / recyclable, renewable, right? And that's a good thing. But there's so many parts of the supply chain that have to work together. It is overwhelming for any one company to coordinate everything. And so if anything, it would be like, I would hope that this change is real, and that people are going to do what they can to reach out to each other right across industries and companies to build a network so that we can get to a place where the material life cycle, if you will, is more sustainable, renewable, recyclable, et cetera, right? And I think that my hope is that because this is something that's more built from scratch, quote unquote, we can maybe do a better job that makes it resilient across disruptions that we're seeing with the chips and everything like that. I don't know if that's possible, but anytime you're doing something from scratch, right, you have both the burden of building something from scratch, but you also have the opportunity to remake the world the way you would want to do it if you could, right?
Absolutely.
Yeah, one point on there that we talk about a lot is around battery supply challenges, and chip shortage falls into that as well and everything. But I would agree with you. I feel like there's an opportunity here for companies to work together around what the supply chain can look like long term, where it is sustainable focused and sustainable in terms of where materials are coming from and how that's done, but also in terms of I guess the overall growth of over time. So like batteries is an interesting example because every company is using different forms of battery technology today when it comes to electric vehicles, or slightly different forms in terms of either cells or flat packs, or and then up to the actual modules that are being developed and everything, which, as we start to ramp up production of electric vehicles, I think it's pretty clear that we're going to have battery supply constraints moving into the future, unless there's some forms of ways that we consolidate that supply chain and kind of work together in terms of how that's going to look. So as a smaller company in this ecosystem today, growing into it, I think we're, optimistic that companies will work together in terms of how that is going to start to form out, so that we can create this world of electric mobility and, everything associated with that does go beyond just battery packs, but that's certainly a big part of it.
Yeah, not too much to add on to those comments. I mean, coming under the umbrella of Hyundai is super valuable for us in this respect. It gives us a lot of experiences and resources around supply chain. I think they have a sustainable vision, electrification, supply chain, cradle to cradle, all of those things. So I think we'll really kind of lean on that. I think what we're reaching for too is scale. We can just create economies of scale and really leverage that for more sustainable production. And I really think we have that kind of set to start going.
Yeah. So on the topic of scale, is that, I think you have one camp that says you can have general purpose robotics that does pretty much everything. And then more realistically, very use case specific robotics, kind of like what we were talking about with Boston Dynamics. And how do we balance this notion of reusing what we have, but yet at the same time being use case specific enough? So in other words, in the case of Hyundai, for instance, you may want to have things that have some aviation capability with on ground, but you may also want to have things that's on ground with marine, meaning water, for example, and different capabilities. How do you reconcile from a product portfolio in such a way that you have distinct set of products, but without having to get so bogged down that you have a product portfolio of, let's say, 500 or 1,000, and it's difficult to scale because you're just not getting enough volume from each of those units?
Yeah, I'd like to hear actually Ryan's viewpoint on this, but I think my feeling is that in the design phase, this is hard to quantify, but I would say if you're starting to make way too many compromises about I need this and that, but not this and this, and then you start, if the bulk of your time is making these compromises across different functions and tasks, then you should call a timeout. It's like, okay, let's not do this. We're negotiating things that are, well, we're spending all the time negotiating about what is and what should not be included. If we simplify the constraints, if you will, or the requirements, we'll get something out the door, kind of a thing. And look, I think cars are a great example. There's so many different types and models and everything, and I think that's, if anything, a precedent to say there's no one world car, right?
Mm-hmm.
Never was, never will be, and I really mean never. And so I think we should take that to heart. And I think I'm hoping that through our collective past experience, we'll say, look, there's a certain practicality, right, that we have to employ when we design a product.
Yeah. How about you, Brian?
Yeah, I mean, it's interesting because Spot is kind of both. I mean, Spot really came to market as a platform, and we do believe it's a platform both kind of at the SDK level and as a general purpose mobility solution. 4 pairs of legs on a flat platform that can carry sensors or even actuators around your environment to do things that are valuable to you. But at the same time, recognizing that early majority industrial markets typically want a solution when they go to purchase something. They want an answer to a business question. They don't want to perform research by and large. So, I think that the platform approach works really well in creating a new market around these types of locomotion and mobility. So creating partnerships, creating people who build technology on top of it, and people who distribute it throughout the world to various industries. But working with partners to make sure that, like, if I'm a construction professional, really what I want is I want something that can scan or photograph my site every day and build a report to me containing the things that I care about, like mistakes and progress every morning. So that's what I want to buy. So I want the laser scanning solution. And yeah, it happens to come on top of, or I want an autonomous laser scanning solution. And yes, it happens to come on top of a Spot robot, but that's not really what I'm buying. So we try to have the sensitivity, like how do we have a really robust platform to essentially create a new market and to allow partners and kind of other companies to build solutions? And then how do we make sure that we work closely with those partners So they get the best of both worlds, our robotics expertise, and then the value out of the partner, so that we're delivering solutions that happen to include Spot to the various industries we serve.
Super. Thank you for that. Our hour is almost up, and I had some more questions for Sam, but Sam, maybe within kind of 20 seconds, if you could talk about next milestones and anything that's upcoming for financing.
Yeah, sure. So, I mean, we just closed our last round in, November of this year. So that's been able to position us well for some of the milestones coming up. We built out our own off-road electric prototype. So that's a 4-motor platform with its own semi-active suspension for allowing for basically us to push boundaries in terms of control for an off-road EV. So we're going to be presenting that in the coming months, like in the summertime. So we'll be able to showcase some news on that, which is going to be pretty exciting. And then, as a part of actually showcasing the technology that we're developing and, becoming a thought leader in this off-road electric space as it starts to move into electric, we're building our own electric off-road vehicle, which will showcase what that future can look like. So there's going to be some new interesting information come out about that in the coming months as well, closer to the summertime.
Amazing. Well, I want to thank John, Brian, and Sam for a terrific conversation on robots and off-road vehicles. Please give them a round of applause. All right, so we're now going to transition to our quantum computing track to talk about quantum ecosystem.